Here's one of the more even remarkable characteristics of water as it changes from one state to another. And by state, I mean from, say, liquid to gas, or gas to liquid, or from liquid to solid. Phase change, that's what phase change is, or state change is. The first point is that it takes 585 calories to evaporate 1 gram of water. Now, whatever, right? So is that something you really want to remember? Well, it is kind of an important number. And the thing is, remember how many calories it took to raise 1 gram of water 1 degree C? Just 1. So here it takes 585 calories, or 585 times that much energy to evaporate water as it does to raise it 1 degree C. So the second point is that 1 gram of water vapor condenses to liquid form. When that happens, the same 585 calories are released back into the air. And we call that the latent heat of condensation. And we've been talking about latent heat a little while earlier in this class. It's come up here and there when we talk about the flow of energy in systems. So in thinking about this, then it takes 585 calories to evaporate, and then that same 585 calories are released. So what this leads to then is a very fascinating topic, and that is in point 3 here. Water evaporated in tropical and subtropical oceans, and that's where most of the evaporation happens. That's where the heat is. Evaporation rates are higher where it's hot, lots of sun. So water evaporated in the tropical and subtropical oceans and carried to the middle and upper latitudes will release large amounts of heat upon condensation. This latent heat transfer moderates temperatures in both extratropical and tropical regions. So to think about that a little bit, then, when we think about the upper latitudes and even middle latitudes as being slightly in energy deficit to extremely in energy deficit during the winter, this moderates their climates quite a bit. The heat of the tropics is brought in this kind of secret magical heat messenger called the latent heat. So all that energy, tropical thermal energy, is tied up. Much of it is brought into the middle latitudes and the upper latitudes, and then when it condenses out in clouds and rain, voila, those 585 calories, which are really solar energy, okay, and their origin, are released. So it very much moderates temperatures in those places. And then also, just to summarize, it takes about 585 calories to evaporate water, but just 100 calories to heat up the water from 0 degrees C to 100 degrees C.